All right, moving on to section 1.2, we're now going to talk about addition. So there's three properties of addition we should discuss, and properties in math are kind of like the rules that are always true. So the first rule that's always true is the commutative property of addition. So if you think of commuting, you might think of moving back and forth, and that's really what this is about. It's saying the order doesn't matter. If we have 4 plus 3, so if we have 4 eggs and we add 3 to it, we're going to get 7. Well, if we started with 3 eggs and then we added another 4 to it, we also get 7. So whether you do 4 plus 3 or 3 plus 4, it doesn't matter what order you add those in. You're going to get the same thing. Think of how that might compare to subtraction, for example. So in addition, they are commutative. There's also an associative property, which is pretty similar. Think of associative, if you're associating with people, you can think of it as kind of like hugging people. And by the way, these properties are listed on your formula sheet, so you don't need to memorize them. You just need to know that they're there and how to identify them. So basically, if you have a group, or let's say 3 or more people hugging, they can hug in any order, okay? So you can have 4 plus 5 plus 3, okay? These brackets say we're going to add the 4 plus 5 first. We'll talk about that more later. But if we add that 4 plus 5 first, we're going to get 9, and then we're going to have 9 plus this 3 on the end here. So we're going to get 9 plus 3, and we'll get 12. Well, what if we added the 5 and the 3 first? So over here, we'll have 4 plus, now that's going to become an 8. So we have 4 plus 8. We also get 12. So it doesn't matter if we add those first 2 digits first, or if we add the 5 and the 3, the second 2 digits, or I guess the second and third 2 digits first. No matter which ones we add first, we're going to get the same outcome. Okay, the last property to note is the identity property, and we'll have some other identity properties come up as well. So if you think of identity, it's kind of like yourself, right? So think of yourself. What could you add to make yourself not change? So if you were a 4, what would you add to yourself so that you didn't change? Well, you could add a 0, right? Because 4 plus 0, you're still going to get 4. Same thing with 7. If you add a 0 to the 7, you're still going to get a 7. So the additive identity property is really just saying you can add a 0 and nothing happens. So that's the third property to note. Okay, a bit of a review of adding digits when we've got, adding digits vertically, I guess. So here we've been asked to add 352 and 546. So we're going to write them down in rows like this. Remember, we're dealing with whole numbers, so the decimal place would be to the right. So in other words, we've lined up the place value of these. We've got the ones positions here, and then we've got the tens here and the hundreds over to the left, okay? So for both numbers, that's true. They're lined up, okay? As long as they're lined up, that means we can go down the column. So let's look at that first column there on the right. So we go 2 plus 6, that gives us 8. Okay, we can go down that next column, 5 plus 4, and we get 9. And then we can go down that third column, 3 plus 5 gives us 8. Okay, and so that ends up giving us an answer then of 898. Okay, what if we need to regroup? What if the math doesn't end up being that easy? So for example, if you look at this problem here, we've got 49 plus 54. Well, if you think of that in words or in kind of its place value, what it means, the 49 is 4 tens and 9 ones. The 54 is 5 tens and 4 ones. All right, well, we'd say, okay, well, let's start by adding up the ones column. Well, now we're going to have 9 plus 4, which gives us 13 ones. We know we can't have 13 ones. The highest our place value can go is 9. So at that point, what you would do is regroup that 13, because you're basically saying 13 is the same thing as 1 10 and 3 ones. Well, now that 110, we can boot that over into our tens group over here. So we had 9 tens. Now we're going to have another another group of tens, to leaving us with 103. Okay, let's just do that the way you probably were taught in school. This way was kind of a neat way to think about the concepts. The way I at least learned in school was I would go, okay, let's go along that ones column. So 9 plus 4, that's going to give us 13. So I'm going to write down the ones position, the 3, and then I'm going to carry on the 1. I'm going to add the 1 up here. So that's basically what we did in this step over here, right? Where we booted over that 10. We're saying, well, we've still got 10 left over. That means it can go into our tens column on the left. Now we can add that column up. So we'll have that 1 on top, plus 4, plus 5. That gives us 10. We'd write the 0 here, and then because we have no other position, we can write a 1 here. Or you could even think of it as carrying the 1 forward and then writing it down there. So we would end up with 103. Okay, next example here, and I'm just going to rewrite it because I like to kind of talk as I do it. So we've got 285, 378, and then we're adding 99. So careful here because they don't all have the same number of digits, right? Our 99 only has 2. We want them to line up at that imaginary decimal so that our ones line up, our tens line up, and our hundreds line up. In this case, the 99 doesn't have anything in the hundreds position, or you could think of it as a 0. There are 0 hundreds there. Okay, we're going to start on the rightmost column and do 5 plus 8. And feel free to use a calculator too for these. 5 plus 8, that gives me 13, plus another 9. Well, if 13 plus 10 would be 23, so 13 plus 9 would be 22. So that's going to give me a 2. I'm going to carry the 2 up here. That 20 now goes up there to be represented as a 2. And then I'm going to do the same for that tens column. So we've got 2 plus 8, that gives us 10, plus another 7 gives us 17. Plus another 9 would give us 26. So we put our 6 down and carry that 20, carry that 2 up to the next column. Now we have 2 plus 2 gives us 4, plus another 3 gives us 7. All right, let's do a few examples. And so with some of these, they'll give you words, and you have to know how to interpret those words. You do have a sheet on your formula pages that can help you with word problems too. If you ever see increased by, we're talking about increasing or adding more to something. So that is going to tell you, that clue is telling you that's addition. So if we have 43 and we're increasing that 43 by 25, that means we're adding 25. So we're going to have 43 plus 25. Okay, we're adding up those ones columns. So 3 plus 5, that gives us 8. Okay, it's under 10, so we don't have to carry over. Woohoo! And then we've got 4 plus 2, so that gives us 6. So our answer here then is 68. Okay, let's do B. Ooh, this is kind of a doozy one, hey? Okay, so let's first line this up. So remember, these are all whole numbers, so you can think of the decimals as being to the right. So pause this video and see if you can line those up. Okay, so let's line these up together to add them. Now we could do it in the order they've given, but I like to put my biggest number first, just because I don't know, I'm a Virgo. So we've got 12,038. Remember, I can change the order of them because addition is commutative and associative. So I've got that 12,038. I'm going to add 325. And then I'm going to add another 68. Okay. And so we've got, well, I want to add the 8 and 8 first because that works better in my brain. So we've got 8 plus 8 is 16. If we add 5 to that, we'll get 21. So we'll have the 1 down here and carry the 2. Then we've got 2 plus 3 is 5. 6, 7 with that extra 2. 7 plus 6 gives us 13. Carry the 1. Then we've got 4. And then here we have basically zeros, like you can think of these as zeros if you want. We were doing 2 plus 0 gives us 2. 1 plus 0 gives us 1. So here's our final answer, which would be 12,431. Okay. And last one, the total. So here's another word that's going to tell you we're talking about addition. The total of 22 and 73. So go ahead, pause this video and see if you can do this one on your own. Okay, so let's do this one together now. So we've got 2 plus 3 gives us 5. Okay, it's under 10, so we don't have to do the carrying over. Yahoo! And then we've got 2 plus 7 is 9. So the answer here would be 95. Okay. Now we've got a word problem. So with word problems, I recommend reading them and then reading them again. It's also a good idea to underline what the question is. So pause this video, read it over a couple times, and then underline what you're trying to figure out here. Okay, let's do this one together now. So Elva won an election with 3,110 votes. Her two opponents received about 1,000 and about 1,200 votes. How many votes were cast in the election? Well, each of her opponents are receiving about 1,000 votes, and then she's receiving about 3,000 votes. The total number, so how many votes is our question. We're trying to figure out the total number. So we're going to be adding these three. So we've got 3,110, 1,022, and 1,211. Okay, what do we have here? Well, on our ones column, we have 3. Then we've got 1 plus 2 plus 1 is 4. 1 plus 2 is 3. And 5. Okay, last step, if you have a word problem, you always want to summarize it in words to show that you understand what you were asked. You can do it in a short sentence, but you should always do a sentence. So we're asked how many votes. So our answer then is there were 5,343 votes cast. All right, the last section of addition is talking about a bit of geometry. So we're going to be talking about perimeter because that involves addition. Perimeter, I like to think of, maybe because I have a little tiny farm, if you can call it that, but as fencing. Perimeter is the amount of fencing you would need to enclose an object. So if you had this very irregular sort of paddock here, with these measurements, how much fencing would you require to go around this shape? So basically what you're doing is adding all of the lengths together. So what I like to do is mark where I start, especially on a more complicated one like this, where they've got many, many measurements. So I'm just arbitrarily deciding to start there. You could start anywhere. So we're adding 7, 2, 8, 3, and 6. Okay, feel free to use a calculator. You have to know how these processes work, but you can use a calculator on them. And I'm going to try to do that one without. So we've got 7 plus 2 is 9, plus 8 is 17, 18, 19, 20, plus 6 is 26. And then I'm going to cheat and make sure that that is right by looking at my key. Yes. Oh, it's right here, 26. Okay. It's important to write the centimeters in too, because it's telling us the unit of measurement. 26 centimeters is a lot different than 26 meters. Okay. Next one. So once again, the perimeter is going to be the sum of the lengths. If we started here, then we could say that's going to be 4 plus 3 plus 4 plus 3. Okay. Another way to think of it, because it's a rectangle, you could say, well, that's the same as 2 times the length. Here, this L represents the length, plus 2 times the width. Okay, so if we did that, we'd say 2 times 4 plus 2 times 3. Either way you do it, you're going to end up with an answer of 14. Okay, but this is kind of a nice way to do it with this formula because it'll help us later on in geometry. All right, a couple here to figure out the perimeter of. So remember your units. The second one is a bit tricky. Pause the video, try that first one, and then give the second one a try as well. Okay, so hopefully you had a chance to try these on your own. Let's go ahead and do them together. So we want to find the perimeter of this first one. I'm just randomly going to decide to start here. So I'm going to add all those sides together. So I'm just going to go around to the right. So we've got 13 plus 15 plus 18 plus 5. And so we get 8, 16, 21. And then we've got 2, 3, 4, 5. Again, you can feel free to use a calculator on that. So we've got 51. So this would be 51 meters. I'll say perimeter, P equals 51 meters for that first one. All right, the second one is more challenging because how the heck are you supposed to do this? You haven't been given all of the lengths, or have you? So one length we're missing is right here. We don't know how long this side is. But if you look over on this side, we know the length of this is 3. We know this other length here is 4. And you can imagine if you added those two lengths together, you're going to get that longer length on the left. So that length is going to be the 3 plus 4. So this length over here is 7 centimeters. Okay, let's take a look at that other one. So we're also missing this length right here, but that longer length here, maybe I'll just kind of try to draw it here. If you think about the whole shape, right, that top length they give you is 6 centimeters, which means this distance down here would also be 6 centimeters. And you've also been told this 2 here. Okay, so if I dropped this down, we know this length from here to here is 2. Okay, so we can actually figure out that other missing length because it must be 6 centimeters minus 2 centimeters, right? Those two side lengths have to add up to 6, in other words. So this length here is going to be 4. Now we have all of our lengths, so let's add them together. So I'm going to start right here, but you could start anywhere. So we've got 6, 4, 2, be careful with these, it's easy to forget one, 3, 4, 7. Okay, and feel free to use a calculator, or it's fun to try to do it without. 10, 12, 15, 19, 26 centimeters.